Hey everyone, welcome back. So you want to really get abstraction in programming, huh? And you sent over some really cool examples like, that online payment system. I think that's a perfect place to start.
It's incredible, really, how much we can learn about writing good code, elegant code, efficient code from something as everyday as, well, paying for stuff online, right?
Yeah, for sure. So let's set the stage here. Imagine you're building this whole system to handle all those online payments, right? And you've got all this complex stuff happening behind the scenes, connecting to banks and all that, encrypting data, handling all the different ways people can pay. It's a lot. So where do you even begin? I mean,
That's exactly where abstraction comes in. Like, instead of getting lost in all those crazy details right away, you start by, well, thinking big picture, you know?
okay, that makes sense. So how would that actually look in practice?
All right, so let's check out your first code example, the one with the, what was it, payment processor and the payment service?
Right.
Now, remember, the payment processor, that's where all the messy, really complex stuff is happening. Yeah, all the nitty-gritty details of talking to the banks and making sure, everything is super secure.
And exactly. But you wouldn't want to expose all that complexity to the rest of your system, or even worse, to the user directly,
Mm,
right? So that's where this thing called the payment service comes in. Think of it as a simplified interface. It's kind of like the middleman between the user and the payment processor.
Oh, okay. So it's kind of like a translator almost, speaking both the language of, the user and the language of all that complex payment processing happening in the background.
Yeah, a perfect analogy. And this separation, it's powerful for a few reasons, you see. So first off, it makes your code much easier to use. The user, or even another developer who might be working on your system, they don't need to understand all the ins and outs of how payment processing works. They just interact with this payment service, which gives them a clean and simple set of methods, like
Hmm.
process payment or refund payment.
Yeah, that makes a lot of sense. It's like using a well-designed API. You don't need to know exactly how it works internally. You just send a request and you get back your response.
Precisely. But it's not only about making things easy to use, right, this separation, it also makes your code way more secure.
Okay, now that's interesting. How so?
Think about it. The payment processor probably has to handle all sorts of sensitive data like credit card numbers and things, right?
Hmm.
But hiding all these complex operations behind the payment service, you're essentially creating a sort of protective barrier.
So it's like putting all the sensitive stuff in, I don't know, a vault or something, and the payment service has the only key.
Exactly. This way, you drastically reduce the chances of, accidental errors or any vulnerabilities that could expose that sensitive data.
Hmm.
And by limiting access to the payment processor itself, you make it a lot harder for, well, malicious actors to exploit any weaknesses if there are any.
That makes total sense. So basically, using abstraction, we're not only simplifying our code, but also making it inherently safer. It's like a two-for-one deal.
Absolutely. And there's another benefit when we haven't even touched on yet, maintainability. How easy it is to keep your code, well, healthy in the long run.
Right, right.
So let's say you need to update your payment processing system at some point. Maybe there are some new regulations you have to comply with, or you want to integrate a new payment gateway or something.
Oh, I can only imagine. That sounds like a pain.
It could be a huge headache,
Yeah.
but abstraction, it makes things much less painful. Since you separated the concerns, you can actually modify that payment processor all you want without really affecting the payment service or any other part of the system that uses it.
So it's kind of like swapping out the engine of a car without actually changing the steering wheel or the pedals or anything like that.
Yeah, you got it. So the user experience, which is represented by the payment service in this case, it stays the same, even though all that complicated stuff under the hood is changing, right?
Mhm. Okay, I'm starting to get a really clear picture of why this whole abstraction thing is so valuable. It simplifies the complex stuff, makes things more secure, and allows the code to change and adapt more easily.
We've only just scratched the surface. Let's move on to your next code example. The one where you introduce this concept of, well, abstract classes. It takes this whole idea of blueprints, to a whole new level.
Oh, okay. I'm ready to go deeper into that. This is where things start to get really interesting, I think.
Absolutely. This abstract keyword, it basically allows us to create a blueprint for different types of payments without actually having to specify all those implementation details right away.
So instead of writing like separate code for credit card payments, PayPal payments, and all the others, we can just like create this one general template and then customize it for each payment type as needed.
Exactly. It's like imagine you have a recipe for, say, a cake. You've got your basic ingredients, your steps, but you can customize like the flavor or the decorations, right?
Okay, I like that. So in our payment system, the abstract keyword helps us define all the core things that every payment type must have, but it doesn't actually say how those things are implemented, right?
Right. So for example, you might have an abstract class called, I don't know, payment, which
Mm.
defines a method called process. And this method, it represents the core action of processing a payment, no matter what type it is.
Okay, so every payment type, credit card, PayPal, whatever, needs to have some way to process that payment.
Exactly. But the abstract class, it doesn't specify exactly how that processing happens.
Yeah.
That's left up to, well, the concrete subclasses like credit card payment and PayPal payment.
So each subclass basically provides its own way of doing the process, tailored to how that specific payment type works.
You got it. And that brings us to one of the most powerful concepts in object-oriented programming, polymorphism.
Polymorphism. I've heard that word before, but I'm not sure I completely understand it.
It's actually a pretty simple idea, but with some pretty profound implications. So polymorphism, it basically means many forms. And in our case, it means that our payment service can interact with any object that follows the payment blueprint, regardless of its specific type.
Okay, let me see if I've got this right. The payment service doesn't have to know whether it's dealing with a credit card payment or a PayPal payment specifically. It just calls the process method, and the system automatically figures out the right way to do it, like while the code is running.
Exactly. That's the beauty of it. It makes your code super flexible and adaptable. You can add new payment types in the future without having to change the payment service at all. As long as the new type, inherits from that payment abstract class and implements the process method, the payment service can handle it without any problems.
Wow, that's impressive. So we've gone from just separating concerns to actually creating this system where you can just plug in different payment types and they'll just work, and the payment service doesn't even have to know the specifics of each one.
Exactly. And that's really just the beginning of what you can achieve with abstraction and polymorphism.
This is blowing my mind already. But before we move on, I'm curious, are there any downsides to using these abstract classes? I mean, nothing in programming is perfect, right?
You're right, of course. Abstract classes, they are super useful, but they do have some limitations. For example, you know how in most programming languages, a class can only inherit from one abstract class at a time?
Right.
Well, that can be a problem if you need a payment type that has to combine, functionalities from multiple different sources.
So it's like trying to make a cake that's both chocolate and red velvet. You can only choose one main flavor to start with.
The perfect analogy. And even though abstract classes can have some methods that aren't abstract, sometimes you really want that, what we call pure abstraction. That's where every method is basically just a placeholder waiting for the subclass to define it. Yeah.
So it's like giving the subclass a completely blank canvas to work with. No pre-filled colors or shapes or anything.
Exactly. And that's where interfaces come in. They offer a more flexible and purely abstract approach. Maybe we can, explore those another time in a future deep dive.
I bet our listeners would love that. But for now, I think we should stick with abstract classes and really see how they work in this payment system example. What are some of the concrete benefits we get from using them here?
Well, one of the biggest advantages is definitely code reusability. So the payment abstract class, it might have some methods for, well, let's say common tasks like validating payment details or logging transaction information, things that every payment type has to do in some way.
Yeah, makes sense. So instead of writing that same code over and over again in each subclass, we just define it once in the abstract class and let the subclasses inherit it.
Exactly. This way you save a ton of time and effort, but you also reduce the chances of making mistakes.
Less repetition, less room for bugs, right?
Exactly. By defining all that shared functionality in one central place, you make sure everything is consistent, and it's less likely to, well, break things.
I'm starting to see how this can really streamline the development process. It's like having a team of super expert bakers who have already perfected the basic cake recipes, so all the new bakers have to do is focus on, well, their own unique flavors and decorations.
I love that analogy. And beyond all that, code reuse and fewer errors. This approach also makes your code a lot easier to maintain. Let's say you need to update some of that shared functionality, you only have to change it in one place, the abstract class.
Oh, so if we find a security vulnerability in the code that validates the payments, we can fix it just once in the payment abstract class, and all the payment types will automatically be more secure.
Exactly. That's a big win for maintainability. It lets you evolve your system over time without having to constantly track down and update every single piece of code that might be affected by the change.
Okay, I'm really starting to appreciate all the power and the elegance of these abstract classes and polymorphism. It's really cool stuff. But you mentioned earlier that they do have some limitations. Can we talk about that a bit? I'm curious to understand when they might not be the best choice.
Of course, you're absolutely right. No single approach is perfect for every situation. It's always important to understand both the strengths and the weaknesses.
Right. So what are some of the potential downsides or scenarios where we might want to consider something else instead of abstract classes?
Well, one limitation that we talked about a little bit before is this whole single inheritance thing.
Mm.
In a lot of programming languages, a class can only inherit from one abstract class, right?
Yeah.
And this can be tricky if you need to create a class that, combines functionality from multiple different sources.
Right, like that whole chocolate and red velvet cake problem. What if we wanted to create a premium payment class that combines elements from both payment and, let's say, loyalty program? And loyalty program is another abstract class. We'd be stuck because we can only pick one parent class, right?
Exactly. Single inheritance can be a real limitation in those cases. And, while abstract classes can have some methods that aren't abstract, sometimes you really want that, what we call pure abstraction. That's where every single method is just a placeholder waiting for the subclass to fill in the details.
So it's like giving them a completely blank canvas, no pre-filled colors or shapes or anything. They start from scratch.
Exactly. Abstract classes don't always give you that level of pure abstraction, which can be limiting sometimes. And then there are also cases where the relationship between the classes, it's more about their shared behavior than a strict parent-child relationship.
Okay, interesting. Can you give me an example of that?
Sure, let's say you have all these different classes that represent different types of reports, like sales reports, inventory reports, financial reports. They might not all share like a common ancestor in the sense of a report abstract class, but they might all need to be printable, for example.
Ah, okay. So the shared behavior is this printability, even though they represent different types of data.
Exactly. And in those kinds of cases, using something called an interface might actually be a better and more flexible approach. Interfaces, they let you define a contract for specific behavior without forcing this strict inheritance structure.
So it's like saying if you want to join this club, you have to be able to do this one specific thing, but we don't care about your family tree or anything like that.
Yeah, a perfect analogy. Interfaces let you group classes together based on shared behavior, not shared ancestry. And that can be incredibly powerful in certain situations.
This is fascinating stuff. I'm starting to see how interfaces can work together with abstract classes to give us even more flexibility in designing our code. It's like we've just opened a whole new door in this exploration of abstraction?
Absolutely. Interfaces, they're a fundamental concept in object-oriented programming. They really deserve a deep dive of their own, don't you think? Maybe we can explore them in detail in a future episode. How about that?
Yeah, our listeners would definitely appreciate that, I'm sure. But for now, let's bring it back to these abstract classes and our online payment system example. We've covered a lot of ground today, from the basics of abstraction to the pros and cons of abstract classes and polymorphism.
Right, and it's important to keep in mind that abstraction, it's a super powerful tool, but like any tool, you have to use it thoughtfully and strategically.
That's a good point. So how can our listeners figure out when abstract classes are the right choice for their projects? What are some key takeaways or, guiding principles to keep in mind?
Okay, so we've got a pretty good grasp on, what abstraction is and why it's so valuable. Now I'm really curious to see how those abstract classes actually work in real code. You mentioned the second example dives deeper into that.
Yeah, let's take a closer look at how you've used them in your payment system.
Perfect. So in this example, I see you have this abstract class called payment, right? And it defines like a bunch of methods, but the one that really jumps out at me is this process method. It's marked as abstract. What does that actually mean?
Good catch. Marking a method abstract basically means, well, you're defining a contract, You're saying that every single concrete payment type that inherits from this payment class, it has to implement this process method, but you don't say how they do it.
Interesting. So it's like you're providing the blueprint, but you're leaving some of the details intentionally blank. Exactly. It's like saying every car needs an engine, right? But the specifics of that engine, whether it's gas or electric or diesel, it depends on the specific car model. In your code, the credit card payment and PayPal payment classes, those are like your concrete car models. They inherit from the payment abstract class, and they have to provide their own specific way of doing the process.
Okay, I see how, that gives you a lot of flexibility. Each payment type can handle the processing in its own unique way. But how does the payment service know which implementation to call? I mean, it can't know ahead of time what kind of payment it's dealing with, right?
That's the cool part. That's where the magic of polymorphism comes in. Remember how we talked about the payment service interacting with a generic payment reference? Well, that reference, it could point to any object that inherits from that payment abstract class.
Right, so it could be credit card payment, it could be PayPal payment, or any other payment type we might add later on.
Exactly. The beauty of polymorphism is that the system, it figures out the right implementation of the process method at runtime. It just knows based on what kind of object it's actually dealing with at that moment. The payment service doesn't have to know the specifics. It just calls process, and the magic happens behind the scenes.
Wow, that's really elegant. So by using, abstract classes and this whole polymorphism thing, we've basically created a system that's super flexible and really robust too. We can add all sorts of new payment types without breaking the existing code, and the payment service, it can just handle all of them seamlessly.
You got it. And this approach, it also gives you a ton of other benefits, like think about code reusability, right? So the payment abstract class, it might have some methods for tasks that are common to, well, all the different payment types, like validating payment details or logging transaction information, things like that.
Right, so instead of repeating that same code in every single payment type class, you just define it once in the abstract class, and then all the subclasses inherit it, right?
Exactly. Not only does that save you like a ton of time and effort, it also reduces the chance of, well, making errors.
Yeah, less repetition, less chance of bugs creeping in.
Exactly.
Yeah.
By defining all that shared functionality in one place, you're ensuring consistency and you're making it less likely to, well, break things.
I'm starting to see how this can really streamline the whole development process. It's like having the central library of, well-tested, reliable code that all the payment types can use.
I like that. It's like having, a team of expert bakers who've already perfected the basic cake recipe. So all the new bakers, they can just focus on their own unique flavors and decorations.
Yeah, exactly.
And beyond all that, code reuse and fewer errors, this approach also makes your code way easier to maintain. Let's say you need to update, I don't know, some part of that shared functionality. You only have to change it in one place, the abstract class, right?
Oh, so if, let's say, we find a security vulnerability in, I don't know, the payment validation code, we can just fix it in the payment abstract class and all the different payment types. They automatically become more secure.
Precisely. It's a huge win for maintainability. You know,
Yeah.
it lets you change and adapt your system over time without having to hunt down and update every single piece of code that could be affected.
Okay, I'm really starting to appreciate the power and the elegance of this whole approach with abstract classes and polymorphism. But you did mention earlier that abstract classes have some limitations. Can we talk about those a bit? I'm curious to know, when they might not be the best fit for a particular problem.
Of course, you're right. No single approach is like perfect for every situation. It's always important to understand the strengths and weaknesses, right?
Right. So what are some of those potential downsides or situations where we might want to consider something else instead?
Well, one limitation that we touched on earlier is that whole single inheritance thing.
Yeah.
In a lot of programming languages, a class can only inherit from a single abstract class.
Right.
And this can get a bit tricky if you need a class that, has to combine functionality from several different sources.
Right. Like our chocolate red velvet cake problem. What if we wanted to create, I don't know, a premium payment class that combines elements from both payment and, let's say, loyalty program, where loyalty program is another abstract class? We'd be stuck because we can only choose one parent, right?
Exactly. Single inheritance can be a real pain in those situations. And, while abstract classes can have some non-abstract methods, sometimes you really want pure abstraction. That's where every method is essentially just a placeholder waiting for, well, the subclass to define what it actually does.
So it's like you're giving them a totally blank canvas to work with. They start from scratch.
Exactly. Abstract classes, they don't always provide that level of pure abstraction, which can be limiting. And then, of course, there are situations where, the connection between classes, it's more about how they behave, what they do, rather than a strict parent-child relationship.
Okay, that's interesting. Can you give me an example?
Sure. Let's say you have a bunch of different classes that represent different kinds of reports, right? Like sales reports, inventory reports, financial reports. They may not all share a common ancestor, like a report abstract class, but they might all need to be printable, for example.
Ah, so they share the behavior of being printable even though they deal with different types of data.
Exactly. And in cases like that, using something called an interface might be a better, more flexible way to go. Interfaces basically let you define, well, a contract for specific behavior without imposing this strict inheritance structure.
So it's like saying, if you want to join this club, you got to be able to do this one thing, but we don't care about your family history or anything like that.
Yeah, exactly. Interfaces let you group classes together based on their shared behavior, not shared ancestry. And that can be super powerful in some cases.
This is really fascinating. I'm starting to see how interfaces can like work alongside abstract classes to give us even more flexibility in how we design our code. It's
Yeah.
like we've opened up a whole new dimension in our exploration of abstraction.
Absolutely. Interfaces, they're really a fundamental part of object-oriented programming, and they deserve their own deep dive, I think. Maybe we can explore them in detail in a future episode. How about that?
I'm sure our listeners would love that. But for now, let's bring it back to abstract classes and our online payment system. We've covered a lot, from the benefits to the limitations of this whole approach.
Right, and I think it's really important to remember that abstraction is a super powerful tool, but like any tool, you have to use it, well, thoughtfully and strategically.
Okay, so how can they decide when abstract classes are the right tool for their projects? What are some key takeaways, some guiding principles they should keep in mind?
Yeah, that's a great question. I think one of the key takeaways here is that abstract classes, they're especially useful, when you have like a clear hierarchy of types and you want to create this like common blueprint, but still allow for some room for customization.
I totally agree. Think of it like building a house. The abstract class is kind of the architectural plan. It lays out the fundamental structure, but it leaves room for variations in the materials, the finishes, even the layout of the rooms.
That's a perfect analogy. So in our payment system, the payment abstract class, it defines the core structure for how a payment is processed.
Right.
But it gives each payment type the freedom to, well, to handle the specifics in its own way.
Exactly. And this approach, it brings all those benefits we talked about, right? Code reusability, fewer errors, better security, easier maintenance, all that good stuff. Right. So if our listener is working on a project where, they see a clear hierarchy of types and they want to enforce a certain structure but still keep things flexible, abstract classes might be, a really good option.
Absolutely. And even if they decide that, abstract classes aren't the perfect solution for their specific problem, just understanding these concepts, it'll make them, well, a much stronger programmer overall.
That's so true. Learning about abstraction and polymorphism, it really helps you think about code design in a more strategic, more sophisticated way. It's like leveling up your programming skills, even if you don't use these specific techniques in every single project you work on.
Couldn't have said it better myself.
Yeah.
It's all about, expanding your toolbox and knowing which tool is the right one for the job.
Okay, so let's bring it back to our listener. We've covered a lot of ground today, from the basics of abstraction to all the ins and outs of abstract classes and polymorphism. What's the one key message you want them to walk away with?
I really want them to understand that abstraction, it's not just some fancy programming jargon, right? It's a powerful tool, a real powerful tool for simplifying those complex systems, making your code safer, more reusable, easier to maintain. And the principles we've been talking about, they apply to way more than just online payment systems, right?
Yeah, that's a great point. Whether you're building a website, a mobile app, even like a complex scientific simulation, these principles can really help you write better code, more elegant, more maintainable code.
Exactly. So listener, next time you're tackling some, tough coding problem, take a step back and think about how you can use those principles of abstraction. You might be surprised at how much simpler it can make your code, how much you can improve your design.
That's a great call to action. And listener, we always love to hear from you. So, how are you using abstraction in your own projects? What other coding concepts would you like us to dive into? Send us a message, and we might just feature your question in a future episode. Until then, happy coding, everyone.